Okay. Hi, and welcome to today's webinar. In today's webinar, we'll talk about how to create material library in Nullspace EM, and how to do the material assignments in different parts, how to do port assignments, and finally how to do the meshing. So we can start by loading the files that the journal file that we ended up last time. So if you open the journal editor and then file open, and then we can open the patch_cat that we had from last time. So if you run this, then we get where we ended up in the last webinar. The next step is to define the materials that we want for the dielectric parts, and also assign the materials. So to make the material library, then we need to use a Python file for that. And then in this case, I'm using a Visual Studio code editor. You can choose the Python editor that you're comfortable with. And then now I've made a Python file called makematerials.py, and there I have imported the nsem library, which is a Nullspace EM library. One thing that is it's quite helpful to do is to set the Python interpreter with the Nullspace Python. So in the Visual Studio Code, then you can select the Python interpreter and then select the Nullspace Python. In this way, if you have the IntelliSense also installed, then you will be able to get the tab completion, which is quite helpful when you want to use the Nullspace EM module. So let's go ahead and then create a new material library, and I will call that ML. So let's go ahead, and now we can see the tab completion. So I want to choose a new material library class, and I want to add the material. So say ML dot, and then I get the add material here. So if I move over on top of the add material, then you can see how I need to define that here. So I need a material class here. So write material, and then the same here. So if I move over that, then you can see how I need to define that. So you need to give it a name, color, and also the way that we define material properties in Nullspace EM is by the complex permittivity and permeability. So we can go ahead and set the name. So we want to define the material for the substrate. So we say, and we're using a Roger for that. So we say RO3003. And let's say we want to give that the color green, and we want to set the material property. So now we can see that we have to use the material property class here. So material property. And the same thing here. So we need to define the properties the way it's defined. So in this case, we want to have a constant over frequency. So we can say constant in the first part, in the first box here. And then we need to define the real part and the imaginary part for the for the permittivity. So we set the real part here. Then you can put the values that you have from the data sheet or from the measurement. So we set the dielectric constant here, and then the imaginary part where we consider the losses over there. So we can say we input the values for that. And then the way that values are assigned as a floating number. So you have to include the decimals here as well. So now we have defined the the permittivity, and then we have to do the same thing for permeability. So, but since this material doesn't have a magnetic properties, then we can set that to free space. So we can set 0 and 1. So now we have done, this is what we did for the Roger, and then we need to add one more material. So you can basically just copy and paste that one and edit the property. So we want to define the material for the connector, which you will use Teflon. So you set the name to Teflon and then change the color to yellow. And also the material property. So we want to change the dielectric constant here, 2.1, and also the imaginary part. All right, so now we have done all the dielectric material that we wanted to add, and one thing to add is that Nullspace EM has the built-in PEC material, perfect electric conductor. So we can use that to assign to the rest of the metal part in our example. And then the last step is to save that. So we can say ml.save and also assign a name for that materials. So go ahead and then save the file, and next step to open the Nullspace EM environment and set the directory to the right location where you have your project files. And in that case, then you can write Python and call the Python file that we created, and then press enter. Now we'll run through the making the materials, and then now we can see that we have added the Roger and Teflon. So now we have done the material library creation, and then we can go back to Nullspace Prep. So now we can go ahead and then load the material library. So one tip is to know which commands to use for the Nullspace EM. Then you can write help and sem. Then you would be able to see all the commands that we can use that the nsem has available. So we can write nsem load material library, and then the name of the file that we created, and then the format .h5. All right, now we have loaded the library, and then we can go ahead and start assigning the materials in different parts. So we can write nsem assign volume, and we want to say assign volume substrate. So we want to assign the Roger to the substrate with the material RO 3003. So now you can see that the color changed to green. So, and if you press up, then you would be able to get the same command, and then we can edit that, and then change that to coax, and then change the material to Teflon. Now you can see that the color changed to yellow for the coax part. All right, so the rest would be basically assigning PEG to different parts. So we can go ahead and start by assigning the PEG to the patch. So it's a patch underscore wall material PEG. Let that turn to gray, and then we can do the same thing for the ground and the pin, the inner conductor of the connector. And one last thing we need to do is to do the outer shell of the coaxial connector. So with that, then we can go ahead and isolate the coax first. From the model to right click and then isolate that. So to be able to see which surfaces to select, then you can go ahead and then press Control and then draw a rectangular, and then you can see all the selection, and then rotate that to see if there is anything left, and then hold the Control again and then select. So you now you can see all the selection that I did. It's popped up in the command line, so you can basically go ahead and then copy that part, and we want to assign those surfaces, so we can write and some assign and then paste the surfaces that we selected. And then material pick. All right, now we have done that. So we can go back to the all visible. So we have done all the material assignment parts. And one last thing we need to do before start to do the meshing is to assign the port. So we can go ahead and from the model tree, select the feed part and isolate that. So now we have the port surface. So we need to define the port and the polarity. So we want to define the top part as a positive one and bottom one as a negative. So you can write down again helps and some. Then to see how we need to define the port source. So write and some. Then you can see here voltage source. So voltage source, and then we need to assign a name for that, port 1, and we want to define the positive surface. So we say surface, and if you select the surface, then you can get the ID for that, 27, and then negative surface, that would be 26. And then we need to define also the impedance here. So then we set the reference impedance for the port to 50 ohm. All right, now we have defined the port as well. And we can go ahead and start the meshing part. So for the meshing part, then from the command panel, you can choose the mode mesh here and then select surfaces. And first we want to set the scheme for the meshing, and then select the mesh, and then we want to set the scheme. So for most of the problems that we use in Nullspace EM, then we use the paving method. So we'll use a paving algorithm to mesh from point A to point B in the surface. So we want to select all the surfaces and then press apply scheme. So now we have applied the scheme, and now we can go ahead and then start the meshing part. Before we start with that, then we want to set the also mesh size, the baseline for the mesh size. So we can make a variable name. Now I will do that in the command line. So we can make a variable name called mesh underscore size. And we want to first calculate the wavelengths and then base that on the wavelength. So if you want to calculate the wavelengths, then we just need to convert first calculate the wavelengths based on the frequency, and the maximum frequency that we want to set is 17 gigahertz. And we need to also convert that from meter to mil, which is the unit that we have for this project. So we need to apply the conversion rate. So that would be the base for the wavelengths. And for the mesh side, then we want to set that 1/10 of the 1/10 of the wavelength. So that would be the rule of thumb. Now we can see that the mesh size we have in the unit of mil. All right, so now we can go ahead and start meshing the port. So, and now you can go from the entity, select curves. And in Nullspace EM, the way that ports are meshed is unique. So you need to have one mesh cell along the common edge of the port, and by that we want to select those curves and set that to one mesh cell. So we can go ahead and then select the curves here. I can select these curves and yes, select the equal method and then select the interval, and then we want to set that to 1. So now you can see we'll have one interval. So, and then if you press apply, then we have we have applied the sizing. And then we can go back to the surface from the mesh, and we want to apply do the meshing size. So we can use the approximate sizing from the menu. And since we already done the sizing on the curve side, then we can go ahead and then select the surfaces. So we say select surfaces in volume feet. Then we don't need to change the sizing here, and then we can go ahead and then apply the mesh. So now you can see that a black line appear outside the port. Then that's the mesh line that you can see here. All right. Then we can go back to the one second. So yeah, so then we can go and then start to mesh the coax part. So with that, then we can go directly from this menu, from the surfaces, and then select surfaces in volume coax. And we want to set the size for that. Since we want to have a quite fine resolution for that, then we want to set the sizing based on the radius of the coax. So we want to set the coax _r and then half of that. So, and then if you press apply meshing, then you would get a warning here that says some entities are already meshed. Do you want to delete and remesh with a new setting? Then we don't want that, since we already meshed the port parts. Then we don't want to redo that. And then if you want to mesh the remaining part, you can use this syntax called select surface not is _ meshed in volume coax. And these syntaxes, you can find these syntaxes in a core form website and with their help. So if you press mesh now, we'll be able to, we have done the meshing on the coax part. So now we can go ahead and then apply the meshing on the patch. So we can go and then select surfaces in volume patch wall. Let's go wall. And we also want to have it quite fine resolution for the patch. And we set that to mesh _ size and divided by 3. So we want to have a quite fine resolution along the patch, since most of the fringing fields are close to the edge of the patch. And then if you press apply, then we have applied the meshing on the patch. So right now we have done all the part that needs like fine tuning for the mesh, and then we can go ahead and then mesh the rest of the parts that is left, and based on the mesh, only the mesh, the baseline of the mesh size. So we can go ahead and then write down select surfaces not is _ meshed. and I will select the surfaces that is not meshed, and then I press apply. Then you will be able to mesh the rest of the parts. Yes, so now we are done with the meshing part. Then I want to show you few examples that few tips that to do after you're done with the meshing. So one tip is to see if you have if there's any surfaces left that is not meshed, then you can write down select surface not is underscore meshed. Then you can see if you write down, if nothing pops up, then that means that we have meshed all the surfaces. And another tip to do is to use the nsem print status. So that will give you a list of information of the interfaces for the materials. Like so here, for example, then if you look at ID number 1, then you can see surface with the ID of 46 is located between the project and the Teflon. So if then we can go ahead and find that surface and then see where that's located. For example, now if I make that transparent and select surface, so 46. Now you can see that that's the top of the coaxial connector part. So that's located between the substrate and the Teflon. So you can track from this table. And if you see anything that says unknown, that means that there is something wrong, and you have to go and check and then assign there's something left that is not assigned and the material. And then here also you have the port information. So where we have applied the port and also the impedance. Yeah, so now we are done with the meshing part, and then the last step is just to save the file. So we can go ahead and write save cube 5, and then we can give it a name 16 gigahertz fetch, and then also the format cube 5 and over right journal. So now we have exported the cube 5 format, and that later on we will import that into Nullspace EM for the simulation. So one thing we can do now is to check the history, what we have done, and then add that to the last to the remaining part that we did. So we can go ahead from the history and then select all the parts that we have done in this part. So we have loaded the material here, and then if you open the generator again and go and then paste that here. So we can go now. You can see what we have done in this webinar. So now we have if you look from the top, then you can see that okay, we loaded the material, we did the assignments of the material here, and then this part then we don't need, so we can just delete those parts. And then we did the port assignment, and we did the meshing. So one nice thing in the journal editor, then you can also write down the comments. So let's say this one for your, if you want to remember something, then you can write down, okay, this meshing part starts here. So that would be quite useful when you want to come back and then know where which part belongs to where. So now then we have set the meshing scheme and then the mesh size, and then we have started to do the meshing part. So for the port, can remove that part, and then also these parts. And then we have started to mesh the coax part. And here for the patch. And this is the rest of the remaining parts. And then we save the file. So if we just save this file, and if you run that again, then we'll be able to get the same results. So with that, then I'll conclude this webinar, and then the next part, then we will use this file in the Nullspace EM simulation and run the simulation and post-process the results.